So here is an example of interface interaction. Now, I was told yesterday you guys actually going to drink this soda. So we're going to use Red Bull instead. You guys drink Red Bull here, yeah? Okay, so let's forget about this guy here. And make believe this is Red Bull. Okay? We're going to make believe this is Red Bull. So Red Bull. Alright. So my question to you is this, my friends. How many teaspoons of sugar do you think are in each can? How many teaspoons of sugar do you think are in a can of Coke? How many teaspoons of sugar do you think are in a can of Red Bull? Okay? So typically what we would do is we would have students come up to the board, two of them at a time, and we have sugar cubes here, and it's telling me that 1 cube equals 1 teaspoon. Okay? So you're just going to help me out here. I'm just going to model this for you. I'm going to pull down these cubes. You tell me when to stop. Okay? Remember, 1 cube equals 1 teaspoon. We're going to do Coke first. Alright, so there's 1. Here's 2, 3, 4, 5, 6. Stop. Stop?
No.
1 more?
I think you should go on.
7.
2 or 3 more.
8.
4.
9. 10.
More or less.
More or less 10? Alright. So we say that there's a value here of about 10. Alright, we're going to try Red Bull now. Same thing. 1, 2, 3, 4. 4? 5? About 5?
5.
Alright. So about half. Okay, so what we can do at this point then is I have a little eraser here, and I'm just going to reveal the answers to you. Okay, so this is real life data. We're going to do Red Bull first. And because I goofed and I made a mistake on the picture I wanted to show you, I'm actually going to tell you what it is for Red Bull. For Red Bull, the teaspoons is actually 6.5. Instead of 10, and there's actually 10. Right? So there's 10 teaspoons of sugar in a can of Coke. Okay, that's a lot of sugar. Now when you think about what just happened, a lot of stuff happened. But did anything really happen up here? Okay? And if you really think about it, the answer to that is probably no. Okay? So this is what we term as interface with, or interaction with the interface. Okay? We're just moving things around. Now that's not to say that this is bad. It's just that if teachers solely stay at this stage, then they never progress through the process of integrating this technology. So how do we move from interface interaction to cognitive interaction, making you think a little more? So let's take that example. And I notice that people don't drink 12-ounce cans anymore, right? They like to drink 20-ounce cans, or these 20-ounce bottles, okay? So these are bigger bottles. And so my question to you is going to be now, how many teaspoons of sugar are in each 20-ounce bottle? Now I'm going to help you out. These are the nutritional facts, okay? And it tells me here that there's 65 grams of sugar in a 20-ounce bottle of Coke, okay? There's 65 grams. So my question to you is going to be this. We're going to forget about that question, and I'm going to ask you this question instead. How many pounds of carrots do you think you have to eat to equal the amount of sugar that you would take in if you drank a bottle of Coke? Okay? So how many pounds of sugar do you think that, or how many pounds of carrots do you think you'd have to eat? So I'm going to give you about 10 seconds. Just talk to your neighbor and see if you can figure that out. How many pounds of sugar, or excuse me, carrots, do you think? And you don't use pounds, you use kilograms? Kilos? All right, so how many kilos?
We have problems converting pounds in kilos.
Oh, okay. So we have pounds conversion. We have conversion. What other missing information do you not have here that's preventing you from maybe solving this problem?
How many sugar has a carrot?
Yeah. How much sugar content is in a carrot? If I don't know that, I'm not going to be able to convert anything, right? So for students, that's what tends to happen. They start saying to themselves, "Wait a minute. I don't have enough information here. What's going on?" Right? And that right there, that little snippet, that little nuance, is targeting what we call cognitive interaction. In other words, now we're having students think more deeply about what it is that we're doing here, and because we did something like this to begin with, we hooked them, right? Because they want to know this. They drink Coke, right? They drink Red Bull. Now, I'll tell you. You want to know the answer, by the way? I'll tell you in pounds, and I think the conversion is. How many pounds per kilogram? 1.6, I believe?
Yeah, 1.6.
1.6. So it's actually 3 pounds of carrots. So we make that conversion, that's how many kilos of carrots you have to eat to equal the amount of sugar content that you would, or the sugar intake that you would do if you drank a bottle of Coke, 20-ounce bottle of Coke, okay? So, there's a third type of socio-cognitive interaction that we'll do in just a minute. But I just want to give you some other background information on mathematics. I'm not going to read through all of these, I'll just leave these here for you. But when you look at the literature on mathematics as a whole, there's certain themes that pop out, and these are it, okay? When you think about really effective instruction for mathematics, right, you tend to think on that for students to learn mathematics, it has to build on prior knowledge. What do they bring in with them, and then how do we build on top of that? How do we give them opportunities to discuss misconceptions? And as teachers, how do we give ourselves opportunities to actually know what misconceptions they're having, right? Because sometimes, as you'll see here in a minute, teachers will ask that question, do you understand? And what do the kids do? Yeah. Right? Does the teacher know? The teacher has no clue, right? Maybe aside from a couple of students that are always answering the question, but what about the kids in the back? Do they understand? So that's really important. Using small groups, working in conjunction with one another, we've known that for many, many years. And this is a really big one. Teachers that encourage reasoning as opposed to just answering, okay? You ask questions that elicit kids to really think about what it is that you're asking instead of just regurgitating something back. In mathematics, there are disciplines that are right or wrong, but there are other disciplines where there might be a correct answer, but the important part is how you arrive at that correct answer, right? So topics like geometry, and that's sometimes a difficult things for students to understand because geometry tends to be abstract, more abstract than say something like learning algebra or number sense. Okay, so if we look at mathematics instruction, and then we look at, well, what about math and these tools? What does the research say about this? So these are some of the things here. And you can immediately see that there's some parallels here, okay? Which is really, really wonderful. I'm gonna focus on a couple of these. One of these is visual representation of concepts, how we represent concepts in different ways. And then how we can develop this kind of active thinking approach that we want students to encounter each and every day. And then the last one here that I'll touch on today is immediate feedback. And I think this is hugely important. For teachers, it's very, very important for them to always attain feedback from students that's in the moment, so that as they're progressing through their lesson, I'm asking you questions, getting feedback from you, and determining what the course of my lesson is going to be from that point forward, okay? Because sometimes what ends up happening is teachers get fixated on, I have to teach this, and this, and this, and this, and this. But what happens if you go to that first level and students take you to this side or to that side? Can you adapt to go to that, to go to those levels and then come back to a consensus at the end? And it's very difficult to do that. Okay, so if you use these technologies, I would like to suggest to you, please, to think about these 6 what we call manipulations. And manipulation is nothing more than an action that you provide in your lesson, within your lesson, to get the most benefit for students understanding a concept. Okay. So the 6 we have here are drag and drop, hiding and revealing color, matching, movement, and feedback. You can see again. So this is nothing more than if you include these types of actions within your lesson, you're going to get the most benefit in terms of how students are actually processing the information, the content that you're teaching. All the meanwhile, throughout this process, it's very important that you're constantly questioning and getting response, questioning and getting response, okay? And we'll talk a little bit more about these and how these particular tools that you have in front of you can help aid in that. All right, so that's kind of the synopsis of the research. The best way to learn about that stuff is just to do stuff. So we're just going to spend a bunch of time just showing you examples so you can see better what we're talking about here. All right, so one of the items on there was hiding and reveal. Let me show you how that works. We're going to do order of operations. All right, you guys remember that? Okay, so I'm going to give you a problem, and I'm just going to give you 30 seconds to figure this problem out. Okay, 30 seconds. So when you find the answer, just like you did before, type in the number, press send, and you're good to go. So here's a question. Can you find the solution to this problem here? Can you find the solution to this problem here? Okay. And you have 30 seconds. But typically what we can do now is I can paste this on the screen and I'm not going to reveal the answer, okay? Now this is something that's really important. Oftentimes teachers like to reveal the answer right away. I think that's a bad idea, okay? Because if I reveal the answer to you right away and you got it right, what then happens?
You lose your attention.
Yeah, that student says, well, learning has finished for me because I already know it, right? And for the students that don't understand, they're sitting there thinking, man, I don't feel so good because I'm the only one that doesn't know it, right? Because that's typically how they think. So we're not going to reveal the answer. Instead, I'm going to prompt you. So when we're working a problem like this, a teacher might say, well, the first step is to do what's inside the parentheses, right, or the brackets, okay? And then the next step that it tells us to do is to work with the exponent or the powers, right? And then after that, we're working with multiplication and division, addition and subtraction, and then finally we arrive at our solution. Okay, now, on the surface level, that seems very simple, right? All I'm doing is just revealing stuff. But here's the power of what's happening here. Notice that we're cueing students by using a little bit of color here, and we're doing it step by step. And the reason we do that is because students that have learning difficulties, specifically in mathematics, if I were to just say to them, let's put this to the side, hey guys, here's the answer, and give that to them like that, they don't know where they went wrong, where it's very hard for them to pick out where it is that they made the mistake. By simply providing this action here of step by step showing them, right, not just what happened here, but then they can revert back to the previous step, it's more explicit in terms of how they're processing that information. Make sense? But still though, we're just simply doing interface interaction, okay? All right, now we're gonna move on from here into something more, something a little bit that's a little bit more different. My first class that I ever taught was to a group of 13 young ladies who none of them wanted to move on to college or to the university. They all want to be hairstylists. Okay, so every morning at 8 o'clock in the morning, they would come in and they would have mannequin heads with whatever hairstyles they had done for homework the night before, and they would put it proudly in front of them, and that's how they would sit for the entire hour that I had them. And my task was to teach them mathematics. Okay, now as you can imagine, mathematics was not something they wanted to learn, right? So when I first started teaching, I would say something like this. If we were working with area, did you know that there's shapes? And shapes have formulas, right? And all you need to know is how to memorize the formulas, because then you can take numbers they give you, plug it into the formula, right? Work it out and you get an answer. So students, please go home and memorize the formulas. All right, that's what I would say to them. Do you think that was effective? Yeah, not at all. Not at all, because they would sit there and look at me and say, it just doesn't jive with me, right?